Hi guys, we're going to do some review of functions. Okay, so hopefully you all remember that a linear equation looks like this. And a linear equation can have one solution, no solution, or infinite many solutions. A linear function just has one. It looks like this. One solution. Okay, now I'm going to do an example. Let's say f of x equals 2x plus 8 plus 3 times 2x plus 4. Okay, this is really important. I want to see every single little baby step when you're doing this. I understand that some of you can jump quickly ahead and do some of this math in your head, but what if you make a mistake? I need to see every single little step you do. So I'm going to walk through this. This would be, oh, hold on one second. How about I give you an f of value? Let's say f of 3. Okay, f of 3 is going to be, go in and fill in 3 for these x's. 2 times 3 plus 8. Now we've got 3 times 2 times 3 plus 4. Okay, let's fix that and make that a bracket so it looks better. Okay, now this is going to be 2 times 3 and 2 times 8. So 6 plus 16 plus 2 times 3 is 6. So 3 times 6. Let's do that. Oops. 3 times 6 plus 4. Now I've got, let's just rewrite this whole thing. 6 times 16 plus 3 times 6 is 18. 3 times 4 is 12. Now 16 plus 6 is 22. 18 plus 12 is 30. 22 plus 30 is 52. And okay, I hope that made sense to you guys, because you're going to need to do a couple of them on a test. I'll give you f of x equals, and then I'll say solve for f of 5, solve for f of 9, solve for f of 1. And as long as you've been watching these videos and you've been paying attention in class, then you got it. For the people that are not watching the videos, this doesn't help any right now because you can't hear me because you're not watching the videos, but you're going to come to a test and be confused. So let me erase some of this. Let's say on a test, I gave you this, and I said, evaluate. That's just a different word for solve. It just means solve. Evaluate for f of 2, f of 9, and let's say f of 5. All you have to do, you know how to do this. all you do is go back and fill in 2 for x and solve it. Fill in 9 for x and solve it. Fill in 5 for x and solve it. That's your answer. Okay, now what we covered in class yesterday, and you had some homework on this. Let's see, f of x. 3, 4, 5, 6, 2, 6, 9, 5. X, f of x, 2, 4, 6, 8, 3, 4, 5, 6. Tell me, are these linear or non-linear? Let's see, what do we do here? Okay, let's find the slope. Find slope. And slope is rise over run, which is y over x. So our y, which is f of x, 2 to 6 is 4, 6 to 9 is 3, and 9 to 5 is 4. So it's not constant. Constant means the same. This is not constant. If it's not constant, we can't give a slope. No slope equals not linear. Let's look at this one over here and let's find the slope. 3 to 4 is 1, 4 to 5 is 1, 5 to 6 is 1, so we've got 1. 2 to 4 is 2, 4 to 6 is 8, 2, 6 to 8 is 2. So y over x is 1 over 2. The slope of this line is 1 over 2. If we've got a slope, then it's linear. One of the math words that we want to use here is constant. Constant means same. If it's a constant change on this side and a constant change on this side, then it's going to be a linear function. If it's not a constant change over here, then it's not going to be a linear function. Let me show you how that works. Go over here. I've made a chart. I have to rewrite these. 3, 4, 5, and 6. And then I did 2, 6, 9, and 5. Let's make these into a graph. Oops, that line's not very good, is it? Okay. Here's my X and my Y. I always want you guys to label your X and your Y. Put an X and put a Y. Okay. 3, 2. 1, 2, 3, 1, 2. 4, 6. 1, 2, 3, 4, 5. Wait, 4, 6. Sorry. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 5, 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. And 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Oh, look. That's not a straight line. There you go, non-linear function. Now let's do the other one. It was x and f of x. I did 2, 4, 6, 8, and 3, 4, 5, 6. 3, 4, 5, 6. I'm going to change colors because I'm just going to use the same graph paper here. 2, 4, 2, 1, 2, 3, 4, 4, 4, 1, 2, 3, 4, 1, 2, 3, 4, 4, 4, 6, 5, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. No. What is normally I would just stop this and start over again, but I'd rather just show you that I made a mistake. This is supposed to be 2, 3, and instead I did 2, 4. So let me erase my mistake. And do you want to know how I knew it was a mistake? I knew it was a mistake because I wasn't making a straight line. And this should definitely be a straight line. So if you've got something that you know is a linear function and you're not making a straight line, you've made a mistake. 2, 3. 1, 2, 1, 2, 3. 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. 6, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 8, 6. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Look at that. Straight line. I also almost made the letter A. Okay, so this one did not have a constant rate of change. No constant rate of change. And because it did not change constantly, it gave us this black curved line. This one has a constant rate of change. And with a constant change, it's always the same here and the same here, we got a straight line. All right, now I just have to show you one more thing. I'm going to show you how to interpret graphs. So let's make, oh, well, I meant for, I don't like to draw in red. Let's see here. Come on, Mrs. Gibbons. There we go, straight line. Straight line. Okay, so here's a typical graph that we're used to looking at. Here's our X, and here's our Y. All I'm going to do is I'm going to erase all this stuff and give you a graph. This is still the x-axis, right? And this is still the y-axis. But I'm going to erase that. We're going to say, I'm going to title this temperature at time of day. Now, down here, I'm going to make the x-axis our hours, and I'm going to make the y-axis our temperature. I have to try to write sideways, and that's a little difficult. Temperature. Look at that, I wrote that sideways. Okay, temperature. I know it's really messy, but okay, hours. Let's say 6 a.m., 7 a.m., 8 a.m., 9 a.m., 10 a.m., 11 a.m., 12 p.m., 1 p.m., 2 p.m., 3 p.m., 4 p.m. Now, for my temperatures, let's say 5 degrees, 10 degrees, 15 degrees, and 20 degrees. At 7 a.m., it is 5 degrees out. At 9 a.m., it's 10 degrees out. At 11, it's 15 degrees. At 1, it's 20 degrees. So tell me, what is the slope of this line? Well, we can say x and f of x. When x is 7, y is 5. When x is 9, y is 10. When x is 11, y is 15. When x is, this would be 13. When x is 13, y is 20. Okay, so let's look and see if we have a constant rate of change. Do we have a constant rate of change? 7 to 9 is 2, 9 to 11 is 2, 11 to 13 is 2, 5 to 10 is 5, 10 to 15 is 5, 15 to 20 is 5. We have a constant rate of change. Slope is y over x. So this is 5 over 2. The slope of this line is 5 over 2. Now, what is the y-intercept of this line? What is the y-intercept? Think to yourself right now. I'm going to be quiet for a minute. What is the y-intercept? Hopefully, you know that the y-intercept is where this line crosses over the y-axis. It means intercept, to intersect, to cross over. If someone is throwing you a ball and somebody else jumps in front of it and catches it, they intercepted the ball. It means to cross over. And this is going to cross over the y-intercept right at 0. So what is the function of this line? F of x equals slope 5 over 2x plus 0. Yay! I hope you got that. Okay, so one more quick thing and then we're done. When you're trying to read a graph, just think of it as it's got all 4 of these sides here. This is the x-axis. This is the y-axis. And it all works the same way. But you need to read what it says. Number of classes. And this one's going to be amount of homework. And as you have more classes, you usually have more homework. So the chart will go like this. But sometimes, what if it's, I don't know, a store puts a certain kind of dress on sale. And after 1 month, each month, the sale gets bigger and bigger, which means the price goes lower and lower. So let's say we're doing sale prices of a pretty dress. Each month, the owner of the shop makes the sale price lower. So we've got price. What month are we in right now? November, December, January, February, March. So let's say $5, $10, $20. Oh, hold on. I want to be $5, $10, $15, $20, $25, $30. In November, the dress cost $30. In December, the dress cost $25. In January, the dress cost, here we are. In January should be here because I'm trying to make a straight line. January, it cost $20. In February, it cost $15. In March, it cost $10. And then in April, how much would it cost? Let me fix those so it looks a little better for you. This is January. February, March, April. Oh, well, I just changed the names of the month. It doesn't really matter. But you should be able to look at this chart, look at the graph, and tell me what happens. If I were to not give you any of this, and I only gave you this graph to look at, you had nothing else, and I asked you to describe what's happening in this graph, hopefully you would be able to tell me, because you looked here, you said sale prices of pretty dress, and you see months and prices. You would be able to write for me in January, the dress cost $30. Each month, the price went down by $5. By May, the dress only cost $10. You should be able to look at a graph and write for me, interpret the graph, and tell me what it says. Okay, bye guys.